Hi, welcome to all to the operating system lab session. As part of the today lab session, we will discuss about our last lab experiment, signal. The signals are fundamental mechanism in operating system. It is used for inter-process communication. It is used for IPC. It is used for IPC, inter-process communication. Using the signal, one process can communicate with the another process without requiring direct interaction. There is no need of direct interaction. Without requiring direct interaction, one process can communicate with the another process. Signal can be generated by operating system, user, or other process. For example, as a user also you can generate the signal and you can send it to another process. Or else one process can generate the signal and it can send the signal to the another process. For example, the parent process can generate the signal and the parent process can send the signal to the child process. Signals are asynchronous notification sent to a process to notify it that a specific event has occurred. In operating system, there are different types of signal. Actually, this table, it depicts the signal name and signal number and description. For example, the signal int is a signal name. The corresponding signal number is 2. The signal int, the interrupt signal usually sent when the user type Control C. The signal term, the corresponding signal number is 15. It is used to know you can terminate the process. For example, the parent process, if it send this signal termination to the child process, then the child process can terminate this, can terminate the process. As part of the today laboratory session, we are going to discuss about three standard signal: signal hang up, signal interrupt, signal quit. The signal hang up, the corresponding signal number is 1. The signal int, the corresponding signal number is 2. The signal quit, the corresponding signal number is 3. Now, without further discussing the theoretical explanation, directly we will discuss with help of the code so that easily you can understand. For example, already I have written a program. I am going to open that program, signal.c. Actually, this is the program. Already I have written it. Now, you see, this I have included the signal.h header file in this program. The signal.h is a header file. This header file contain all this constant signal hang up, signal int, signal quit. All this constant which is defined and it is available in this header file. That is why I have included this header file. Actually, you see the signal handler is a function. It takes the signal number as a input. Then accordingly it will match. Suppose if the user generate the signal hang up signal, then the handler function, it will receive that 1. Then it will match up with this case. Let's assume the user generated the hang up signal. The signal number contain 1. Then the 1 it is passed to the switch case statement. In the switch case statement, you have to compare this case. The 1 is equal to 1. This condition is true. So this printf statement will be executed. This printf statement will print received the signal hang up. Actually, this is the signal handler function. I have written it. Now we will discuss the main program so that you will understand. You see, there is a signal function. This function also written and it is available in the signal.h header file. Uh, I have included 3 signal function. Basically this signal function, the first signal function registers the signal hang up. The signal hang up. The second signal function, it is registered for signal end. The third signal function, it is registered for signal quit. In the program, you see I am using the while loop. In the main program, I am using this while loop. This main program, it keep on execute. Actually it's a infinite while loop. It's keep on execute. There is a sleep second. Okay, this main program it keep on execute. Here I have created the three signal function. I have registered with respect to the signal hang-up, signal int, and signal quit. This function also it's keep on. I have registered. The main program also it's keep on running. Now, for example, when the user generate signal hang-up, then this signal hang-up. No, when the user generates signal hang-up, then what will happen? The signal handler function is invoked. Then the signal hang up value 1, it is passed to the signal number. Then it will match this switch case. Then it will print receive the signal hang up. Let's run this program so that easily you can understand. For example, I'm going to compile gc signal.c. Now the a.output file is created, right? I'm going to type a.out. You see, the program is it's keep on running. Now as a user, actually in my command prompt, I'm going to press Control C. When I press the Control C, as a user, now I have generated the interrupt signal. If you press Control C, then automatically it will generate the interrupt signal. Then that interrupt signal, it is passed to that function. In the function, no, it matched with that case statement interrupt. Then it is print received the signal interrupt, and the program is terminated. Again, I'm going to run this code to show the signal hang up and to show the signal quit. For example, as a user, let's say actually I have opened one more window. Actually, this is the program. In the program, it is running to receive the different types of signal like signal int, signal hang up, signal quit. Now, I'm going to, as a user, I'm going to generate signal hang up. As a user, if you want to generate the signal hang up, you have to use this kill command, then use the minus signal hub, then you have to give the process ID. With respect to our case, the process ID is 14863. Then what will happen? As a user, I have generated the signal. You see that program, it received that signal, received the signal hang up. Now, as a user also, I can generate the signal quit. For example, if you want to generate the signal quit, you can use this kill command minus signal quit, and you have to give your process ID. What's the process ID? 14863. Actually, it's the process. The process is very simple. As a user, I am generating this signal quit, and that signal quit. No, I am sending to this process 14863. I am generating this signal quit. I am sending to this process. That is why you see I have printed my current process ID, right? When I press this command, what will happen? When I press this command, you see my program, it received the signal quit and it is terminated. Okay, now in this example, we have written one simple program. In the program, now we have registered the three signal, and now the program wait for the three signal to happen. As a user, when I am generating the signal hang up or signal quit, that program it capture that signal, and now it print that signal status that the signal is received. Now we will discuss one more program. For example, with respect to inter-process communication, we will discuss one more program. For example, let's assume in this program, you see, already I no need to explain. I have used this fork function. Using the fork function, I have created the parent and child process. This is the code for child process. This else block is code for parent process. You see in the parent process, actually you see when the statement is executed, if the fork fail, it will print that error, the fork is failed. Suppose if the fork success, for the parent process, it return this PID. Okay, the PID contain the for the parent process, no, the fork, it will return the child process ID. That's why the child process, the parent process contain, the PID is there, right? The PID contain child process ID. Now you see, in the parent process, no, I am generating the signal. Here now, this parent process is generating the signal that it is sending to the child process. Now the PID contains child process ID, right? That's why the parent process, it generates the signal hang up, and it is sending to the child process. Then it is sleep for the 3 seconds. Then the parent process, it is generating the signal end, and it is sending to the child process ID. Then as well as the parent process, then it is sleep for the 3 seconds. Then after that, the parent process, it generates the signal quit, and it is sending to the child process. Actually, this PID contains child process ID when this fork function is executed successfully. If it is fail, it contains -1. Okay, that is why we are checking with this condition. Now I am going to run this code, and we will see. GC lab1 lab1 I have executed, then a dot out. You see, the parent is sending signal hang up to the child process. Then the child, I have received the signal hang up. Signal number is 1. The parent is sending signal into the child. Then the child is telling, I have received the signal into 2. The parent is sending uh, signal quit to the child. Then the child is replying, I have received signal quit from the parent. 3. Then finally the child is telling, I am terminated now. Okay. Basically the signal is a service. It is provided to the operating system one process to communicate with the another process without requiring any direct interaction. There is no need of any direct interaction. If you know the process ID, using the process ID, one process can communicate with the another process. As a user also, I can communicate with the another process with help of the process ID. If I know the process ID, directly I can able to communicate. I can pass the signal stating that you can terminate, or else you can restart, or else you can quit. There are different types of signal. It's available. Using the signal, one process can communicate with the another process. Thanks for listening. Uh, Please complete your record all 10 experiment, and you can submit and you get your signature as early as possible.